AI just decoded bird migration signals. They're avoiding regions for a concerning reason. In 2023, AI analyzing routes across North America, Europe, and Asia found birds suddenly abandoning paths used for thousands of years, rerouting mid-flight around specific zones, revealing a hidden environmental change already affecting global ecosystems. The pattern that shouldn't exist. In 2023 analysis, AI systems studying global migration patterns detected something unexpected across major flyways in North America, Europe, and parts of Asia. Birds that normally follow fixed seasonal routes began shifting away from specific regions, breaking patterns that had remained stable for thousands of years. These routes are not random. They are inherited behaviors refined over generations. What made this discovery unusual was the consistency across species. Migratory birds like geese, storks, and swallows, which do not interact or share habitats, showed the same directional changes. These deviations were not gradual. Instead, they appeared suddenly within a few migration cycles, suggesting a rapid environmental trigger rather than long-term adaptation. Researchers initially considered weather or food supply changes, but the scale did not match typical seasonal variations. By 2022 tracking, migration routes had remained largely unchanged, making the sudden shift in 2023 data stand out clearly. The adjustments were also precise, with birds avoiding defined zones rather than drifting randomly. This led to a key observation. The behavior appeared coordinated, even though the species were independent. The alignment across different populations suggested that something external was influencing their navigation systems at the same time. Whatever triggered this shift was not isolated. It was affecting multiple regions simultaneously, altering patterns that had been consistent for centuries. As analysis expanded through 2024 models, researchers confirmed that these deviations followed repeatable paths across different migration cycles. Birds approaching the same regions would adjust direction at nearly identical points, maintaining consistent distance from the affected zones. This level of precision suggested that the trigger was stable, rather than temporary. Data also showed that younger birds, migrating for the first time, followed the same altered routes, indicating that the response was immediate rather than learned over time. The consistency across age groups and species reinforced the conclusion that a shared external factor was actively reshaping global migration behavior. The data that exposed it. The discovery became clearer when AI processed large datasets collected from GPS tagging, satellite tracking, and weather radar systems across North America, Europe, and Asia. During 2023 studies, millions of recorded flight paths were analyzed, revealing consistent detours around the same geographic zones. Birds were not simply shifting slightly, they were rerouting mid-flight, sometimes adding over 300 kilometers to their journeys. These detours followed similar arcs across different species, even when their original migration paths had no overlap. This level of consistency ruled out random variation. The data also showed that these changes occurred in real time. Birds approaching certain areas would adjust direction before entering them, maintaining distance without visible environmental barriers. This behavior repeated across multiple flyways, suggesting a shared response mechanism. By comparing patterns from 2020 data to those from 2023 tracking, researchers confirmed that these deviations were recent and not part of long-term change. The cause did not appear linked to a single species or habitat. Instead, it pointed to an external factor affecting multiple ecosystems at once. This level of coordination, detected only through large-scale AI analysis, highlighted something that traditional observation could not capture. The patterns were hidden in plain sight, only becoming visible when millions of data points were examined together. The regions birds are avoiding. As AI mapping improved during 2023 tracking, specific regions began standing out due to sharp drops in migration activity. In eastern China, particularly near industrial zones around Beijing, bird traffic showed clear gaps where routes once passed consistently. Similar disruptions appeared across Central Europe, especially in areas like Germany and Poland, where flight paths became fragmented rather than continuous. In the United States, data from 2022 studies highlighted unusual gaps across the Midwest and parts of Texas, particularly near dense infrastructure and radar-heavy zones. Coastal regions such as the North Sea and sections of the Baltic also showed increasing avoidance patterns, with birds rerouting before reaching these areas. What made this more complex was that even remote regions, including parts of Siberia and northern Canada, showed similar behavior despite having minimal human activity. These zones formed patterns that researchers began describing as invisible corridors, areas consistently avoided without any visible barrier. The alignment of these regions across continents suggests a shared factor influencing behavior. The avoidance is not scattered or random. It follows specific geographic patterns, indicating that whatever is affecting these routes operates across multiple environments at once. The magnetic sense we don't have. Bird migration depends heavily on a natural ability known as magnetoreception, allowing them to navigate using the Earth's magnetic field. Studies from 2020 research confirmed that birds can detect extremely subtle shifts in magnetic signals far beyond what humans can sense without instruments. This ability guides them across continents with remarkable accuracy. Their navigation relies on stable magnetic patterns that remain consistent over long distances. Even small disruptions can cause major changes in direction. By 2023 analysis, researchers observed that birds were not simply getting lost, they were actively adjusting their routes before entering certain regions. This behavior suggests that something is interfering with the magnetic field at a scale large enough to influence multiple species. Unlike weather or visual cues, magnetic changes are invisible, making them harder to detect without specialized tools. However, birds respond to these shifts immediately, altering their paths in real time. The consistency of these adjustments across different species indicates that the disruption is not localized. It affects broad regions, aligning with the same zones identified in migration data. This connection between navigation and avoidance strengthens the idea that the cause lies in changes to the Earth's magnetic environment rather than isolated external factors. The magnetic field is becoming unstable. Recent measurements from 2023 studies show that the Earth's magnetic field is not as stable as it once was. Scientists tracking long-term changes have confirmed gradual weakening across certain regions, along with shifts in magnetic intensity. One of the most studied areas is the South Atlantic anomaly, where the magnetic field is significantly weaker than surrounding regions. This anomaly has been expanding over time, with data from 2020 research indicating noticeable growth in its range. At the same time, localized distortions have been recorded across parts of Europe and Asia, creating irregular zones where magnetic readings behave unpredictably. These variations are subtle to human instruments, but can be highly significant for species that rely on magnetic navigation. Birds depend on stable magnetic patterns to guide them over long distances. When these patterns shift, even slightly, their internal navigation systems can become unreliable. Observations from 2023 tracking show that birds are not entering these unstable zones, but are instead rerouting around them entirely. This behavior suggests that birds are detecting areas where their natural compass no longer functions correctly. Rather than risk disorientation, they avoid these regions altogether. The alignment between magnetic anomalies and migration changes strengthens the idea that the Earth's shifting magnetic field is directly influencing global movement patterns. The role of human technology. Alongside natural changes, human-made electromagnetic activity has increased significantly in recent years. By 2023 data, regions with dense infrastructure, such as major cities in North America, Europe, and Asia, emit continuous electromagnetic signals from communication systems. These include signals from towers, satellites, and radar installations operating across multiple frequencies. Studies conducted during 2020 experiments showed that birds exposed to artificial electromagnetic noise can become disoriented. Their navigation systems, which rely on subtle magnetic cues, can be disrupted when stronger signals interfere with those natural patterns. This effect becomes more noticeable in areas with concentrated technological activity. Migration data reveals that many of the region's birds are avoiding overlap with areas of high signal density. In locations where communication infrastructure is extensive, birds adjust their routes before entering these zones. This pattern has been confirmed through 2023 analysis, where avoidance behavior aligns with regions of increased electromagnetic output. The combination of natural magnetic shifts and artificial signal interference creates an environment where navigation becomes less reliable. Birds respond by rerouting to maintain stability in their migration paths. This interaction between natural systems and human technology highlights how environmental changes, both natural and artificial, can influence behavior on a global scale. Environmental collapse signals. By 2023, researchers began linking migration changes to broader environmental shifts across North America, Europe, and Asia. Climate patterns that once remained stable are now changing rapidly, affecting temperature cycles and seasonal timing. These shifts directly impact ecosystems that birds depend on during long-distance travel. One of the most critical factors is food availability. Many species rely on specific stopover points that have supported them for generations. However, studies from 2020 research show that these locations are changing or disappearing due to habitat loss, pollution, and altered climate conditions. In industrial regions, air and water quality have also declined, making certain areas less suitable for survival. Birds depend on precise timing and location during migration. When these conditions change, their routes must adjust. Data from 2022 tracking revealed that birds are no longer stopping in areas that were once essential for rest and feeding. Instead, they are bypassing these zones entirely, even if it means traveling longer distances. This pattern suggests that avoidance is not only about navigation, but also about survival. Regions that once supported life may no longer provide the conditions needed for migration. As these environmental pressures increase, birds are forced to adapt quickly, reflecting a direct response to changing ecosystems rather than gradual evolutionary shifts. The sudden route changes that shocked scientists. The most unexpected discovery came from how quickly these changes occurred. During 2023 analysis, scientists observed that some species altered their migration routes within a single season. This kind of rapid shift is unusual, as migration patterns are typically stable and passed down over generations. In several cases, entire flocks rerouted their paths by over 1,000 kilometers, abandoning routes that had been used for centuries. These were not small adjustments, but large-scale changes that appeared almost immediate. Data from 2022 tracking confirmed that these same routes had remained consistent just 1 year earlier. AI systems classified these movements as non-random behavioral anomalies, meaning they did not follow typical patterns of variation. Instead, the changes appeared coordinated and purposeful across multiple species. This level of consistency suggested that the trigger was both recent and significant. The speed of these shifts indicates that birds are responding in real time to environmental changes. Rather than adapting slowly, they are reacting immediately to conditions that affect their ability to navigate and survive. This behavior highlights how sensitive migration systems are to disruption, and how quickly they can change when those systems are affected. Birds as early warning systems. For decades, scientists have observed that birds often respond to environmental changes before humans can measure them. Studies from 2020 research showed that migratory species react quickly to shifts in atmospheric pressure, radiation levels, and magnetic disturbances. Across regions like North America, Europe, and Asia, these responses have been recorded long before instruments detected clear changes. Birds rely on highly sensitive biological systems that pick up subtle environmental signals. These include changes in air composition, electromagnetic variation, and even ground-level instability. During 2022 observations, unusual bird behavior was recorded in areas later linked to ecological stress, showing that their reactions are often early indicators rather than delayed responses. Their migration patterns function like a global monitoring system. When multiple species begin adjusting routes at the same time, it reflects a shared environmental trigger rather than isolated behavior. By 2023 tracking, researchers confirmed that these changes were not random, but aligned with specific regions showing environmental variation. This makes bird migration more than a seasonal movement. It becomes a signal system, reflecting changes across ecosystems in real time. When these patterns shift, they provide insight into conditions that may not yet be fully visible through conventional measurement methods. The warning hidden in the sky. Migration systems are among the most stable natural patterns on Earth, with routes remaining consistent for thousands of years. Data from 2020 studies confirmed that these paths rarely change unless influenced by significant environmental factors. However, by 2023 analysis, researchers observed repeated avoidance of specific regions across North America, Europe, and Asia. Birds were not simply drifting off course. They were consistently avoiding the same zones across multiple migration cycles. These areas matched regions identified earlier for magnetic disruption, environmental stress, or high electromagnetic activity. The repetition of this behavior across different species reinforced that the cause was not random. AI did not create these patterns. It revealed them by analyzing millions of data points that were previously too complex to interpret. What appeared stable for centuries is now showing signs of disruption, visible only through large-scale analysis. The consistency of these changes suggests that something is altering conditions across multiple environments at once. Migration routes are adjusting to maintain stability, even if it means abandoning long-established paths. This shift reflects a system responding to pressures that are still being studied, but clearly present on a global scale. As 2023 analysis continues to unfold, bird migration is no longer seen as a fixed system, but a changing signal across North America, Europe, and Asia. Routes that held steady for thousands of years are now shifting with precision, not randomness. Birds are not wandering, they are actively avoiding specific regions, repeating the same patterns across multiple seasons. These movements suggest that something in the environment has changed at a scale large enough to influence entire ecosystems. AI did not create this pattern. It revealed it by connecting millions of data points into a clear signal. What once looked like normal migration now points to a deeper shift already in progress. The behavior of birds shows that changes are happening before they are fully measured or understood, turning migration itself into a visible trace of unseen environmental pressure